In this episode, we will construct a LCR circuit where the resistor and inductor are in series with the voltage source and one capacitor and a resistor is in parallel with the same voltage source. We will apply a PWL source and transient analysis to observe the time domain response of the circuit. We will apply an AC input voltage whose frequency we will vary over a long range to observe the frequency domain response of the circuit. So stay tuned, stay focused. Hey guys, welcome back. Today we are constructing the LCR parallel circuit. So here the circuit will consist of a resistance and an inductance in series and a capacitor and a resistance. It will be in parallel, obviously with the input voltage source. Now we will have two kind of variation with this circuit. First, we will analyze the transient response by giving a PWL source at the input and the transient analysis for the final waveform. Next, we will observe the circuit's AC response by assigning a small signal AC voltage at the input, and we will apply the AC analysis to see the AC behavior, that is the frequency response of this circuit. Before going to the circuit construction, I would like to emphasize that you are already familiar with the keyboard shortcuts and we will be using these keyboard shortcuts in the circuit construction today. So here is the LTSpice icon. Let me double click and open it. The LTSpice window has opened. Now I'll go to the new schematic button to open the dashboard for schematic drawing. First, I'll save the file with a particular name. For that, I'll go to File, then Save As. So I have given the name LCR Parallel Circuit 1 and I'll click the Save button to save the file with this particular name. You can see that the name of the file which we have just given is coming at the top leftmost corner here. Now let us proceed for the circuit construction. For that, I will hit V from the keyboard as a voltage source and I will place it here. Right click to vanish it. Now I will hit R from the keyboard. Here R comes, that is the resistance comes, and I will click Ctrl R to rotate it. So I will rotate it and place it here. I will right click to vanish it. Now I will hit L from the keyboard. This will introduce the inductor. Again, I will click Ctrl R, again Ctrl R, again Ctrl R for the inductance to be in the right orientation. I'll click and place it, right click to vanish it. Now the series resistor and the inductor is placed. Now it's time to place the parallel capacitor and the parallel resistance. So I'll hit C from the keyboard. Here you can see the capacitor has come. I'll right click to vanish it. Now I will hit R from the keyboard and I'll place it here. Right click to vanish it. I'll click Save. Now all the components have been placed. I'll do the interconnection. For that I'll hit W from the keyboard. I'll connect here, go up, connect here. I'll connect these two. Then I'll connect, go here, come down, connect with this. Then I'll connect here, come down, come at right, go up and connect here. The final thing remaining is the capacitor. I'll connect it here and connect this to the ground. I'll right click to vanish it. I'll go and save the file. Now the ground line has been defined, but physically the ground has to be defined. For that I'll hit G from the keyboard. As the ground symbol comes up, I'll click here. I'll right click to vanish it and then I hit W from the keyboard and I'll click here, go up and click. I'll right click to vanish it. Now the ground line has been properly connected. I'll click Save to save the file. Now all the placeholders are there. Let me turn on my marker pen. You can see the voltage source is here, the series resistance with the voltage source is here, the inductance is here, the parallel capacitance here and the parallel resistance here. And we have placed the ground. So the circuit construction is done for the LCR parallel circuit with first type of configuration. Why I'm saying this? In the next episode, we'll see another kind of orientation. I'll vanish the pen and here now we'll assign the values. The R1 we give 60 ohms value. The L we give 1.5 millihenry and for the capacitor we give 2.5 microfarad. Okay, and his R2 resistance will be of 20 ohms. Okay, I'll click save here. Now I will right click here in the voltage source and I'll give the PWL by clicking on advanced, and then I'll go to the PWL. I'll give the PWL value. And one thing I would like to mention here, in the theoretical episodes I have described the graphics as well as the definition as well as the description of the PWL source. Please go ahead and watch the respective episode from the same playlist where you are finding this video. So there I have read about the PWL. Here this is a practical hands-on episode, so I'll not go into the theories in detail. I'll just assign the values, construct the circuit, simulate and analyze the results. So I'll go here, I'll put 0, then at the voltage value I'll put 0, then time I will put 10 nano, then I'll put 10 volt, then at 20 nano I'll put 10 volt. The values need to be rechecked: 0, 0, 10 nano, 10 volt, 20 nano, 10 volt. So all these are set. I'll click OK to save the PWL here. Now it's time for the transient analysis to be configured. For that I'll go to the SPICE directive and I'll write .fan. I'll click OK to save it. Now I'll right click and I'll give the values 1M, then 0, then 5 micro. In the theoretical episodes, I have already explained about the transient and its different components. So please go ahead and watch that episode to understand the transient. Here we will assign the values, construct the circuit and simulate and analyze. So here I have given all the transient values and you can see the transient command is constructed here. So I'll click OK to modify this. Now I will click save and then I'll click on fit to screen so that the entire circuit has come. Now the entire circuit is there and I'll click the run button to run the simulation. Now as the simulation has completed, I'll go to view, then SPICE output log, and I cannot find any error or warning here. So that means our circuit construction and the simulation run is okay. I will double check the SPICE netlist by going and view SPICE netlist, and here you can see the PWL source is here. Here we have a resistance, inductance, capacitance, resistance, and we have a tran, that is the transient analysis, and we have a very simple and clean SPICE file. So I'll go ahead and close this SPICE netlist here. Now as the simulation has completed, I will display the waveforms one by one. I'll first display this one. From the keyboard, I'll hit B to make room for others. Okay. I'll take the voltage here across the series resistance. Next, I'll hit B from the keyboard. I'll take the voltage across this inductor by clicking and dragging the icon and releasing here. Okay. I'll hit B from the keyboard again. And I will click, hold, drag and release here for the capacitor. And obviously these two will be same because these two nodes are same. So this same waveform conforms to both the capacitor and the resistors, that is C1 and R2. Now you can see as the PWL start from 0 and move to a value and stays there, right? So the capacitor has a charging action here. Okay. Similarly, the voltage goes on here and it stays here and it comes back to some time and the inductor has fallen down. So the three components, that is the R, L and C, is behaving differently. These things you have read in your textbook in the college level. Now you can see the transient response of each of the component. Here nothing more to verify. In case at your end you want to play with the values of the resistances, capacitance and the inductance to see how all these waveform changes, you can go ahead, make changes here, 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 and then you can do the simulation again to see how the waveform is changing. Okay, so that is up to you, and I am done here with the transient analysis. Now I'll close this graphics window. I'll make the circuit larger here. Now I'll right click here and here I'll click cancel and edit text directly. So here I will make it a comment. I'll click OK. The reason I am doing this is now we will proceed towards the AC analysis. I'll click save. I'll go and right click on the voltage source here and this window comes, right? So here I'll click none and I'll use a small signal AC, that is 1 volt here. Here you can see I'll apply a small AC amplitude here and I'll click OK. Why I'm doing this? Because I'll be implying the frequency change through the AC analysis, and that's why I'm not mentioning any frequency here. And I'll go to the SPICE directive and I will write here .AC. I'll click OK and I'll place it here. I'll right click on this. As soon as the dialog box come, I'll select first the decade I'll use 10 points per decade. Start frequency will be 10 Hz and the stop frequency will be 10 kilohertz. So you can see the AC command, that is the LTSpice command, has been constructed here. So this way we will observe the frequency response of the same circuit for which we have already seen the transient response. Now I will click on OK to apply this AC analysis and I'll click save here to save this file. Now again I will run the simulation. Here I'll go to view, then Spice output log, and here by looking closely I cannot find any error or warning. So our simulation is okay and we have nothing to debug here. I'll click and close this. Our circuit is already checked in the last analysis, that is the transient analysis. I'm not going in that direction. So I'll come here. First, I'll go ahead and I'll click here, hold, drag this. Okay. So this is a flat AC voltage. Okay. So let me hit B from the keyboard to make room for the others. Now I will click on the resistor, hold, drag and release. So in this particular waveform, you can see there is one line, there is another line. So here one is the dB response, another is the phase response. Okay, that is the amplitude and the phase, because the AC has two parts, one is amplitude, another is frequency. Now I'll click here, hit B from the keyboard again, and then I'll go click here and I'll click here, hold and drag. I'll click here and then I'll hit the B from the keyboard and then I'll go click here, I'll click this point, hold, drag and release. Now let me bring my marker pen here. This is the original voltage, that is this one, and the AC response as we see across the resistor, right? That means the frequency variation in x-axis, right? We are varying the frequency from 10 Hz to 10 kilohertz, okay? And in decade. So this is 1 decade, second decade, and like that it goes on. You have a logarithmic graph at your end. You can check these decades. So these are prominently displayed there. Now, as we come to the waveform, this is the waveform of the resistor, that is this one. This is of the inductor and this is this one. And the dotted line in all the cases, right here, 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 these are referring to the phases, that is the phase angles here. That means on the right hand side y-axis, and the solid lines right here are referring to the left hand side y-axis, that is the amplitude in dB, that is the amplitude response. So this is for the inductor and this one is for the capacitors. So in a circuit, if we apply a transient analysis and a AC frequency analysis, we can see two different kind of graphs. And why we do this? Because we want to study what happens if we give a kind of fixed pattern input waveform to see the variation with time in the transient analysis that we have already done. That is one thing, that we test how the response changes with time, and for the time window we take a ample amount so that the entire operating range of the circuit is covered. Now it is the time domain analysis, and when we come to this particular AC analysis, we come to the frequency domain analysis. Here we vary the frequency and see the response of both the amplitude and the phase. And the previous case it also was there, the amplitude and phase was also there. Here we see how the amplitude and the phase response changes if we have a small signal input and its frequency is varied over. This generally we do with a signal generator in practical laboratories where we use breadboards and physical components, right? Here we are doing this. So this way we can test our circuits, both the transient response and the frequency response, that is the time domain analysis and the frequency domain analysis. We have shown both of them in this particular episode. So we are done here with both of the analysis, that is the time domain analysis, that is with the transient, and the frequency domain analysis, that is with the AC frequency analysis. We are done completely, and thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.